In an investigation of environmental causes of disease, data were collected on the annual mortality rate, deaths per 100,000, for males in 61 large towns in England and Wales. In addition, the water hardness was recorded as the calcium concentration in the drinking water. The dataset also notes for each town whether it was south or north of Derby. Is there a significant difference in mortality rates in the two regions?
Hi class, my name is Professor Nacho, and today I will be explaining to you how to perform a two-sample t-test for means. This is very exciting stuff, I promise. So, in this problem, the first thing we have to do is make up two hypotheses. The null hypothesis and the alternate hypothesis. In the null hypothesis, you always say one mean is equal to another. So in this problem, we're saying the mean of the men mortality rate north of the city Derby is equal to the mean of the mortality rate south of the city Derby. And then in the alternate, we're saying those two means are not equal to each other. You could either say they're not equal to, greater than, or less than in this type of problem, but this frappy is calling for not equal to. So we have four conditions: the randomization condition, the 10% condition, the nearly normal condition, and the independent groups condition. Gosh, I can't contain my excitement. Oh my goodness. Okay, so for random, it is reasonable to assume that both the population of men in the north of Derby and in the south of Derby are representative of both of their populations. You use that phrase for every single two-sample t-test for means that you do. It is reasonable to assume that the sample of whatever you are dealing with is representative of the population of whatever you are dealing with. Even if it doesn't say so in the problem, you just say it anyway because it's reasonable to assume. But if it does say it in the problem, you say stated because clearly it's in the problem. Alright, next condition, 10% condition. Now, the sample size for the north was 38 and the south 27. You just multiply those both by 10. I think you can do that without a calculator, so 380 and 270. Now, it is reasonable to think the population of men in the north is greater than 380 and the population of the men in the south is greater than 270. Moving on to the nearly normal. Now, in the book, there's two box plots. This is for the north, and this one is for the south. Alright, so the north, you can see it is clearly symmetrical. The median seems to be in the middle, so the mean seems to be in the middle. Now, you see this little outlier up there. You might want to say something about that in your nearly normal condition spot. You might want to say, since there's an outlier, we will proceed cautiously. Now, once you get to do a lot of frappies, you will realize that often you get to these conditions that aren't met, and you just proceed anyway, even if all of these conditions fail. Heck, I'm going to do the t-test anyway. And you just go on, you say cautiously. Because everything you did doesn't matter as long as you say the word cautiously, because then you're not promising anything. Alright, so you say something about that little dot right there, and you move on to the one for the south. And you see that it is pretty symmetrical, and it is pretty on both sides even, so you can say that it's okay to presume with an approximate normal model, but cautiously, since you don't know if they're both unimodal, since it is a box plot and they don't give you data points. Now, moving on to the independent groups. It is reasonable to assume the sample of men north of Derby is independent from the sample of men in the south. Alright, now that all conditions were met, we must write all conditions are met, so we can proceed to calculate a two-sample t-test for means with degrees of freedom equal to 53.49. Now, how do we know that? We use the calculator. It's a secret. You're supposed to know how to do it, but the calculator is much easier, and we AP statisticians are really lazy. So, why do we have to write this long sentence? Because the AP Statistics graders love to see it. Do you want P's on your exam? I don't think so. So just write it so you can get all E's. Alright, now to find a t-score. This is the formula. Alright, y hat of the north minus y hat of the south minus, you don't have to write this part, that's why it's in parentheses, but mu of the north minus mu of the south. Now, this is just supposed to equal to 0. Your null hypothesis said so, so it's just kind of redundant to write it, but I'm just showing you that this is the actual true formula. And then this is over the standard error of y hat north minus y hat south. And that is the square root of the standard error squared of the north over the population of the north, well, the sample population of the north, the sample of the north plus the standard error of the south squared over the sample of the south men. Alright, now that you know this, I will show you how to plug it into calculator so you can get these great numbers. We are excited! Moving
to plug into the calculator, we first turn the calculator on. Then we hit the start button. We go all the way over the tests, and we choose the 2-sample t-test. Now, since we don't have any data or L1, L2 lists, we go over the stats. And first, you put in the first mean, which for us is the mean of the north, and it is 1631.59, also known as 1,631.59. Next is the standard deviation of that sample, which is 138.47. Now we move on to sample size, which is 34 in this first sample. Now we move on to the second sample of men in the south, which is 1,388.85. And now it's the standard deviation of that sample, 151.114. And then you just plug in that sample size, which is 27. And they give you 3 options, and you the first one, which is not equal to, because that is what this problem calls for. Next, it gives you 2 options, pool data or not pool data. We always choose no because the AP Statistics makers of the test do not want you to learn how to pool this data. So you just move on and always say no. Now we calculate this t-test. Now it gives us all these values, our t-score, our p-value, our degree of freedom. Look at this stuff. This is just so great.
Alright, class, now you just plug all those numbers into your already made formula. Really easy, one step, you just plug them all in and you get the t-score of 6.47. The AP Stats graders don't need to know that you didn't do this by hand and you just use the calculator, so you just gotta play their game. Alright, now you draw the student T model. How is it different from the normal model? Well, it's obvious. The ends are so much wider. Look at that. The variance in those. Now, you make sure to write your t-score on the bottom. And it's equal to 6.47. And for this, we're shading in both sides. So this one is equal to 6.47 as well. But what's the difference? It's negative. Don't forget that negative sign. All right. And then you put your p-value and 2 little arrows towards it, which is equal to 0.000000003, approximately 0. All right, this is really interesting stuff. With that p-value, what do you think we're going to do? We reject the null hypothesis. This is so exciting. Look at all the stuff we're learning. All right. Now we're moving on to the most important part of this t-test, our conclusion. Without this, your reader's not going to know what you did. Like, how are they going to know what you're concluding? All right, you're going to say, with a p-value of 0.0000003, approximately 0, and an alpha of 0.05, we reject the null hypothesis. Rejecting it because our p-value is smaller than our alpha. There is sufficient evidence to suggest that the true, make sure you put true, population mean mortality rate of men in cities north of Derby is different because our alternate was that they are not equal. Then the true population mean mortality rate of men in cities south of Derby. This is almost the same for every single conclusion you do for 2-sample t-test for means. you always start out with comparing your p-value to your alpha. If the p-value is smaller, you reject. If it is larger, then you fail to reject. You never accept the null hypothesis.
Now, since you just did a two-sample t-test, we are going to do a two-sample for means confidence interval. Your confidence interval gives you a value for the difference between these two groups. Instead of just a, yeah, they're different, or nah, we don't think they're different. You give you an actual number. So it's better. So, what's great about this is we follow the same conditions. The random. You want to make sure that your population sample is representative of the population. 10%, nearly normal, to make sure that our sample follows a normal distribution. Independent groups, to make sure that the groups are independent, because if they weren't, we would have to do a different kind of test. These four conditions, which we already checked with the test, they are the same. Now that we have made sure all the conditions are met, we can proceed with the confidence interval for two means. Alright, and using an approximately normal model, because we're using the student's T model, which is not normal, which we already discussed earlier, with degrees of freedom 53.49, which we are going to find using the calculator, and I will show you that later. The formula for this is y bar of the north minus y bar of the south plus or minus t-score, which I will show you how to calculate later, degrees of freedom times standard error of the north squared divided by the sample size of the north plus standard error of the south squared divided by sample size of the south. Alright, plugging in numbers, we know that the mean of the north, because of what they've given us in the book, is 1,631.59, and we know the mean of the sample of the south is 1,388.85. Subtract those two, alright, plus or minus. I will show you how to find the t-score right now.
To find the t-score, you will need to know two things. One, you will need to know the area. And to find that, we are using a 95% confidence, so subtract 1 minus 0.95, divide that by 2, and that is your area. Alright, now we will go to second bars, inverse t to find the t-score, do the area, 0.025, and our degrees of freedom, which we already know from calculating the other problem, 53.5. Paste, calculate, and you have your t-score, 2.005. Now I will show you how to calculate this interval using the calculator so you can save time and not have to do arithmetic. Go to Stat, Test, 2, Sample T, Interval. Luckily, we already put in the correct data because we did it in the other problem. So you will see that all this data is the data that pertains to our problem. Confidence level, 0.95 because we want to be 95% confident. Pull up, no. Calculate, yes. Okay, and now we're going to calculate and find our interval, which is 167.45 to 318.03.
Now that we have calculated the confidence interval, which is 167.45 through to 18.03, we need to have a conclusion. What does this mean? Alright, so what we're doing is we're comparing the mean men's mortality rate in cities north of the Derby to the mean men's mortality rate in cities south of the Derby. So we're going to put this in our conclusion. We are 95% confident. Always start off saying how confident you are, because you don't want to be misleading. You're not 100% confident. This is in fact, you're only 95% confident that the true population mean mortality rate, make sure you're specific about what you're talking about. We're talking about the mean mortality rate. How much do these guys die? Okay? Of English and Whale men, also be specific here. What kind of men? Is it men or women? What are we trying to conclude about? We're concluding about men who are English and Whale in these cities, because that is what the sample consists of. North of the Derby, these men north of the Derby, is 167.45 to 318.03 deaths per 100,000. Make sure you include the units of what your numbers mean. Greater than the true mean mortality rate of men in cities south of Derby. We are comparing the north to the south. And because the numbers in our interval are positive, we know that they are both a greater than.
Thanks guys for hanging with us. Have a happy, frappy day.